Let's work some problems involving vectors. This first one, the vector v has initial point P and terminal point Q. Write the vector v in the form of ij. So they're giving us basically 2 points, and the vector goes between these 2 points. Q is the terminal point. I is the initial point. It's very straightforward. You just take the terminal point minus the initial point. And since these are points, you're going to take the x of the terminal point minus the x of the initial point, and then the y minus the y. So for the terminal point, it's 110. And I'm going to subtract the initial point, which is 4, 4. So this is now going to be like a vector. I'll put a vector sign. So 1 minus 4, negative 3. 10 minus 4 is 6. Now to write that in ij form, you would say vector v would be negative 3i plus 6j. All right, not too difficult. Next problem I want to look at is, well, I guess we'll do one more of these just for practice. Same thing. Terminal point, initial point. The vector is going to be 4 minus a negative 1, 5, minus 8 minus a minus 1. That's negative 8 plus 1, negative 7. So therefore that vector should be 5i minus 7j. Now here is a vector. They want to know the magnitude. So the magnitude of a vector is the square root. You take the I part and you square it, and you add to it the j part squared. (144 plus 25). Turns out this is a nice whole number. So the magnitude is 13. All right, so you have some problems like that. Now, sometimes they have us do some sort of math problems with vectors, like in this case. We have 2 vectors, v and w. So I'm going to multiply vector v by 3. This 3 is called a scalar. We're going to multiply vector w by 4 and then add them together. This is pretty straightforward. Let's just see what 3v would be. 3v simply means multiply 3 by both parts of my vector. So 12i minus 15j. And 4w, multiply 4 by both parts of the w vector. So minus 12i plus 8j. Now, if I have room, basically what I'm going to do is going to add these together. So you simply add up the I parts. It looks like the I parts cancel out. 12i plus a negative 12i. So there is no I part. Negative 15j plus 8j looks like negative. So that should be the answer. negative 7j. All right, next problem's interesting. They give you two vectors, v and w, and they want to know, here's what they're looking for, v minus w, and then take the magnitude of that vector. So you're going to have a v minus w, which ends up being a vector, and then they want the magnitude. So it's really a two-step problem. The first step is figure out vector v minus w, and then once you have that vector, we're going to go take the magnitude. So v minus w should be pretty straightforward. You take the I of the v minus the I of the w, so 4 minus a negative 2, which is like 4 plus 2. And then negative 6 minus negative 4. So there's this vector v minus w. Now to take the magnitude of that, let's see if we have our little formula where 6 squared plus negative 10 squared, like 36 plus 100. Get rid of 136. Now we have to see if that simplifies. So let's see if like 4 goes into it. I don't think 4 does. How about 9? Oh, sorry, 4 does go into it. 136 divided by 4, I think it was like 34. 34 times 4, yeah, 136. So we can bring a 2 out. It's like 2 square root of 34. Another problem. So what's different? Notice this one up here, you subtract the vectors and then take the magnitude. This one, we're going to take the magnitude of v, the magnitude of w, and then subtract the magnitudes. So I have to figure out magnitude of v, which is 6 squared, 36, minus 6 squared. It's really 2 times 36. Of course, 36 squared is 6, so this is going to be 6 square root of 2. And then the magnitude of w is another square root. 4 squared, which is 16, plus the negative 5 squared, which is 25. Looks like square root of 41. So since they want an exact answer, you would just say 6 square root of 2 minus square root of 41. Here's another problem. So they give us a vector v, they tell us the magnitude and direction, and they want us to rewrite this vector in the ij form. This is pretty straightforward. We have those equations where if our vector v, if we call it ai plus bj, A is going to be the magnitude of the vector times the cosine of the angle. In this case, it's alpha. And B would be the magnitude of the vector times the sine of the angle. So just plug in. Magnitude's 3. Cosine of 45 degrees. Magnitude's 3. Sine 45 degrees. Now, just as a sanity check, I really encourage you, every time you do a problem like this, make a quick sketch of your initial vector so that when you get your answer, that'd be a good way to check to make sure it looks like it makes sense. So 45-degree angle is right here. Let's just say a different length of 3. So it should be somewhere here in the first quadrant. These are special angles. Let me see what the instructions say. Type an exact answer. Using radicals as needed. Yep. So they're saying what an exact answer. Cosine of 45 is square root of 2 over 2. So 3 times square root of 2 over 2. Sine of 45 is square root of 2 over 2. So 3 times square root of 2 over 2. So when it's all said and done, you would say vector V is 3 square root of 2 over 2I plus 3 square root of 2 over 2J. Not too difficult. Now let's flip the script. Now they give us a vector in the IJ form, and they want us to find the angle. So the vector (7i plus 7j). If we make a quick sketch of that. 7i means 7 in the I direction, or the X direction. 7j means 7 in the Y. So let's look at the first quadrant. Now the angle could be the tricky part with these. The equation we're going to use is the angle is inverse tangent of y over x, where y is the j part, x is the I part. So 7 over 7. Looks like they're looking for the answer in degrees. Now hopefully you already know this. What's the inverse tangent of 1? So we're in the first quadrant. We're looking for an angle where the tangent is 1. Hopefully it's pretty clear that that's going to be 45 degrees. Maybe we'll do another one. How about this one? Inverse tangent of y, or the j part, over, and once again they want it in degrees. I mean, if you want, sometimes this will work, especially if it's a special angle. I mean, we can simplify this. 11s cancel. I know students like to grab their calculators, even though sometimes you shouldn't use it or not supposed to, but we'll see what happens here just for fun. So I'm going to put 1 over square root of 3. I'll make it negative. I'm in the degree mode. Hit inverse tangent. All right, now the thing I didn't do yet, I didn't make a plot of this. So, looks to me like got a negative I, which means negative x, and a positive. So it looks to me like it's probably actually over in the second quadrant. But what this is saying is the angle's over here. Well, that's another case where the inverse tangent doesn't really give us the correct answer immediately. Have to use some common sense. So this is really the angle I'm looking for. Sometimes I'll put a little tick mark there. This is the angle my calculator and the inverse tangent function gave me, but I know it's not the correct answer. But I know if this angle here is, this is a 30 degrees, that means this one's 30. So if I'm going to find this one, I can take 180 minus 30. And you actually get the answer to be 150 degrees. So the angles can be a little tricky sometimes, so be careful. The first answer isn't always the correct answer. One last one. The direction of this vector minus 8i minus 5j. And you notice here, instructions round to 1 decimal place. So this is definitely not going to be a special angle problem. So, inverse tangent the I part minus 5 over the I part, so the y, the j part over this. Now if I were to draw a quick sketch over here, this is definitely, these are both a negative. My guess is this may be right about here or something like that. So we're definitely in the third quadrant. Now I need to use my calc. This is not a special angle, so basically inverse tangent of 5/8. $32.005, and it says it wants to 1 decimal place, so 32.0. Well, that stuff. So this is going to be our angle. Well, that's definitely not a 32-degree angle. So it must be a reference angle. 32 degrees would be like right here. Hopefully you can see what I need to do now. I need to take 180 plus 32, since this is also 32 degrees in here. So it's really going to be should be like 212. 180 plus 32, 212 degrees. All right, so those are the kinds of problems you have to do with a lot of vectors. Now there are a couple of story problems I'll do, but I'll save that for the next video.